Now today in class 12th I will take the combination of resistances. Now there are two combinations of resistance, one the series combination and second the parallel combination. First we see the series combination. Series combination of resistances. When resistors are connected end to end so that same current passes through them. It is called series combination of resistances. The resistors in series combination are at different potential differences. So all the resistors have the same current, but the potential difference across them is different. So now let us take these are the three resistors and this is now resistance R1, this is now resistance R2, this is now your R3, this is now point A, this is now point B, this is now point C, and this is now point D. So one end of the resistor is connected to the another end of the second resistor, and the second end of the second resistor is connected to the first end of the third resistor. So this connection is continued, and let the current through them is I. Let this is the cell. This is now key K. This is now cell of EMF E. So it carries a current I. Here the current is I. The potential difference across this is let B1, and that equals to this. This is now B2, and then let this is we take the point A. This is now point B. This is now point C, and here we have the potential difference V3 across this. This is now point D. This is now point D. So now the potential difference V1 is equal to IR1, V2 equal to IR2, and V3 equal to IR3. This combination follows the law of conservation of energy. So total potential difference V is equal to V1 plus V2 plus V3, and this is now your IR1 plus IR2 plus IR3. You take common R1 plus R2 plus R3. This is equal to now V. So this V upon I is equal to R1 plus R2 plus R3. V upon I is the equivalent resistance. This is equal to R, equal to R1 plus R2 plus R3. This is now like this, where V upon I is equal to R, the total resistance or the equivalent resistance. The total or equivalent resistance. Equivalent resistance. Now from here you can see that the total resistance is equal to the sum of the resistances connected in series. Thus, total resistance is equal to the sum of resistances connected in series. And now this resistance R is greater than any of the resistance in the series. The total resistance R is more than any of the resistance in series combination. यानी इनमें से किसी भी रेजिस्टेंस से ज्यादा है. Suppose now this is now 1 ohm, 2 ohm, 3 ohm, then this is now 6 ohm. 3 ohm is the maximum one, so this R is more than the maximum resistance connected in the series. The series combination of resistances follows the law of conservation of energy. तो ये बोर्ड में ही पूछा जाता है that the series resistance is based on which of the fundamental law. So that case we have to answer the conservation of energy. So to obtain maximum resistance, the resistors must be connected in series. तो ये R का मान मैक्सिमम होता है, इसलिए अगर आपको मैक्सिमम रेजिस्टेंस गेन करना है देन ऑल द रेजिस्टर्स मस्ट बी कनेक्टेड इन सीरीज. So this will reduce the current in the circuit. When the resistance is more, the current is less. The series combination of resistances reduces the current in the circuit. Now suppose we are having resistance of which are n resistors are connected in series of equal resistance. We name it by EQ. EQ means equivalent. Let n resistors of equal resistance are connected in series. We have n resistors which are at the equal resistance and then they are connected in series. So then how much they total the equivalent resistance? So equivalent resistance is equal to n. This combination of resistance has one drawback. That it has actually the two drawbacks. First one, that all the resistances are at different potentials. So if suppose n bulbs are connected in series, the voltage will be divided. So this combination acts like a potential divider. So the bulb having the more potential will glow more, and having the low resistance will have the all the potential difference having the low, then it will glow very less, or this will be the dim one. So now we have the disadvantage of this series combination also. Disadvantages. Disadvantages are what? First is if any of the resistor stops working or damaged, the remaining resistors will become inactive. अगर सीरीज में रजिस्टर्स लगे हुए हैं और उनमें से कोई भी एक रजिस्टर खराब हो जाए, डैमेज हो जाए, if suppose that does not act, then remaining all bulbs will stop functioning or they will be inactive. This combination works as potential divider. So if electric bulbs are connected in series, then bulb of low power will glow brighter than any other bulb. This combination works as a potential divider. So if electric bulbs are connected in series, then the bulb of low power will glow brighter than any other bulb. So bulb of the low power means that it has the low resistance and then it will have the high voltage. So this will operate at a high voltage and then this will glow more than to any other bulb in the series. So here we have that the intensity of brightness is inversely proportional to the power. So this is the series combination of resistances. Now I will take the parallel combination of resistances. Now if I take the uses of this the series combination of resistance is used in your resistance box, post office box, etc. The series combination of resistors is used in resistance box, that we call the RB, post office box, this is called the PO box, etc. So this series is series combination resistance is used to make the resistance box where we are having a large number of resistances which are connected in series, and also the post office box there is also the number of resistances which are connected in series. Now I take the second combination. This is the parallel combination. Parallel combination. When one end of each resistor is connected at one point and other end of each resistor ends of each resistor is connected at another point. It is called parallel combination. Parallel combination. The current in each resistor is different but all resistors are at same potential difference. Same potential difference. In case of series, we are having the same resistance, the same current in all resistors, but at different voltage potential differences. Here, all the resistors are at the same potential difference, but they are having the different currents. This combination follows the law of conservation of charge. तो ये जो कॉम्बिनेशन है वो कंजर्वेशन ऑफ चार्ज पर बेस होता है. So now let we are having the three resistances. This is now point A and this is now point B. This is our resistance R1, this is now R2, this is R3. And they are at the same potential. This is now potential B. So here we are having a cell. Here the current is I. Then this current is divided at this point A in the three parts. This is I1, this is I2 and this is I3. And then all the currents are combined at this point B, and this again there is the current I in the circuit. So here the division of the current is according to the resistance. Higher resistance will have low current and low resistance will have high current. So now you can see now here I1 equal to V upon R1, I2 equal to V upon R2 and I3 equal to V upon R3. Potential difference is the same, resistances are different, and you can see from this that higher the resistance, lower the value of the current. So what we have? The total current. Total current I is equal to this is I1 plus I2 plus I3. This is in accordance with the law of conservation of charge. So this is equal to V upon R1 plus V upon R2 plus V upon R3. This is equal to I. Here we take V common from all. 1 upon R1 plus 1 upon R2 plus 1 upon R3. This is equal to I. So this is now I upon V, and this is 1 upon R1 plus 1 upon R2 plus 1 upon R3, and this is equal to 1 upon R. So this is equal to 1 upon R equivalent. R equivalent. equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. This is not so much. Where this Req is equal to V upon I, the equivalent resistance. So now you can see that the equivalent resistance, the reciprocal of the equivalent resistance is equal to the sum of reciprocals of the resistances connected in parallel. Thus, reciprocal of equivalent resistance Req, equivalent resistance, is equal to the sum of reciprocals of different resistances, resistances in parallel combination. This is the reciprocal of R1, this is the reciprocal of R2, reciprocal of R3, then this is the reciprocal of equivalent resistance. So this R equivalent is the minimum resistance, then any of the resistance connected in parallel. The R equivalent is minimum than any of the resistance in parallel. इस R का मान इनमें से सभी से कम होगा. It means that suppose R1 equal to 1 ohm, R2 equal to 2 ohm, R3 equal to 3 ohm, then R equivalent is less than the 1 ohm. So R is the minimum, then the least resistance in the parallel combination. So to obtain a minimum resistance, the resistors must be connected in parallel. To obtain minimum resistance, the resistors must be connected in parallel. If suppose we are having the different bulbs which are connected in parallel, then you can have that the bulb with the higher power will glow brighter than the low power bulb. The electric bulb of will glow more than low power bulb. Low power electric bulb. So here the brightness is directly proportional to the power of the bulb. Higher the power, higher the brightness. This is why that you see that the bulbs connected in series, the battery is one which have the more power. So now the parallel combination of resistors is used to make electric circuit in houses and डेमोक्रेसीज। अपने घरों में जो बिजली का जो ये सभी लगे हुए हैं, they are all are in parallel combination, and this is why that they always act at the same voltage. So in our houses the voltage is 220 volts. So every equipment and every the electrical appliance works at the same voltage, 220 volts. Also in decorations we use the different kind of bulbs of the different colors, and they all are connected in parallel. So they act at they are working at the same potential of the source. So they glow according to their power. So this also, when the resistance are connected in parallel, then the resistance is very less, so the current is high. And this current, because of the current is high, then this is divided in the different equipments or the appliances connected in the parallel. So because of that, all the equipments are working at the same potential of the source, that is 220 volt in our houses. If either of the equipment stops working, then remaining all will continue to function. They will not stop to work. If any of the equipment stops working or damaged, the remaining equipments will remain active they will not be inactive. In parallel combination. तो ये इसका सबसे बड़ा फायदा है। जैसे अपने घर के अंदर का मान लो कोई एक बल्ब खराब हो जाए तो इसका मतलब ये नहीं है कि सारे बल्ब खराब हो, नो, दे विल कंटिन्यू टू स्टार्ट. So if either of the equipment or any of the equipment in our house or in the decoration lights is not functioning, then remaining will continue to function. So this will not stop the other equipments not to work. So this is what the very good use of the parallel combination of resistances. So this is what now the main points to be, suppose there are n resistances of equal value and connected in parallel. Let n resistors, each of resistance are connected in parallel. मान लो n रेजिस्टर है, उनको पैरेलल के अंदर हम सबको लगा देते हैं तो इक्वल रेजिस्टेंस कितना होगा? The equal resistance. Resistance. Now this 1 upon R equivalent equal to 1 upon R plus 1 upon R plus 1 upon R plus and so on up to n. Up to n. Then what we have? That this 1 upon R equivalent equal to n upon R. So what we have? This R equivalent is equal to R upon n. R upon n. So this is the equal resistance when the same resistors are connected in the parallel. This is about the series combination and the parallel combination of resistances. So what is asked in the exams? First we ask the fundamental laws on which these combinations are used, and some given the appliances like the post office box and then the resistance box, and then we also ask that if suppose the bulb and so what are connected in parallel, then which of them will glow more, which of them will glow less, or you are given the comparative glowness, and also if they are connected in series, then which of them will glow more, which of them will not, will dim one. Then there is also the comparative glowness of the bulbs. So this is also to be asked that in our houses or the decorations, which kind of combination of resistance is used, so that we can have this from the study of parallel and the series combination of resistances. Thank you.